Look at here is the third tutorial example preloaded in OpenBDLM, where we have regime switching during time series analysis. So what we're going to do, we're going to open OpenBDLM. So type OpenBDLM main. Then what we're going to do is, again, use the interactive tool in order to load a new data set. So we're going to type 0. What is the project name? We're going to call it here example underscore disp, because we're analyzing some displacement, and we're going to call it anomaly. So we're going to use here that regime switching to detect the presence of anomalies in time series. So return, do we want to generate synthetic data? No. So we want to build a new database, option 0. We have our tool that's opening. We go in data. We want to load raw CSV file. And our data is an example disp anomaly. We select that CSV file. It's added, done. So OpenBDLM is going to take care of preloading the data. And we're going to see that here we have a large chunk of missing data indicated by these red crosses here. So we can close it. We can see here we can have high variability in the time step. So the most common time step is going to be 12 hours. This is the points that are here. But we can have a lot of variability in the length of each of our time steps, and BLM is going to adapt to it. There's no problem. So what we can see is that the chunk of missing data corresponds to this missing window, where, for instance, the sensor could have been broken or problem with data acquisition. In any case, we have nans in place of the observations here. And this is not a problem with OpenBDLM. We're going to see this. So the total fraction of missing data is here 9.8%. Okay. So for this time series, no more changes. We're just going to save and continue. So option 7, once again, OpenBDLM is going to place or print those figures. We can close them. It's the same figure as before. So now the specificities is the first time we're going to use 2 model classes. So how many classes we want? We want 2. So what is the first model class? So here we're going to choose 23, 31, and 41. So 23 is going to be here a local trend compatible with acceleration. So our model 1 is going to be a constant speed degradation model combined with a periodic component with a period of 1 year to represent our external effects. And 41, this is our residual term. Perfect, I type return. So (11), sorry, 23, 31, 41. Okay, perfect. So my second one is going to be 13, 31, 41. So 13 is what is local acceleration. So my first model that represents the normal state is going to be a model with constant speed baseline. My second model, which represents the abnormal state, is going to be one where acceleration is allowed. So instead of using 23, I'm going to use 13. Type return. Oh. Here's just a 13, 31, 41. Okay, perfect. I just touched an arrow that I shouldn't have here. So whenever you have mistakes, you're going to have redundancy with respect to this. So identify the shared parameters. So here it's important because we have 2 different regimes, but these 2 regimes share the 31 and 41 components. So what we want to tell OpenBDLM is that these last 2 components share the same parameters. So what we're going to do here is that we're going to say exactly as proposed. We have 3 components. The first components, which are 23 and 13, don't share parameters because they are different baselines. But then the next 2 components are sharing the same parameters. So we're going to type 1 and 1. Then we can type return. So it's not going to double the parameter value. They're going to share both the same parameter value. Perfect. Everything was created. Then first step we can do is to learn the parameter value. So we're going to choose option 1 to learn the parameter value, and we're going to choose here Newton-Raphson optimization 1. Okay, the optimization start. Again, as usual, this may take several minutes to learn the parameter. Keep in mind, learning a parameter is a relatively long process in comparison with estimating hidden states. Okay, now what we've done is I've skipped this step. Okay, now if we want to skip this step of optimizing the parameter value to speed up, what we can do is to go in OpenBDLM and directly load the config file where I already have preloaded the same configuration and already run the optimization. So I'm going to type return to load this file, and I can use it. So what I'm going to do here, since the hidden states, the parameter were already optimized, what I'm going to do is I can estimate the initial hidden state, or directly estimate the hidden states for this time series. So here we're going to choose to start by estimating the initial hidden states, option 2. So keep in mind that the initialization or estimation of initial state won't produce any output. However, the results from this procedure is going to be stored in memory. So when it's done, I can use option 3 to estimate my hidden states. And I can choose here, for instance, smoothing, option 2, type return. And we're going to see once the Kalman filtering process is completed, all my time series appearing on the screen. Perfect, it's completed. What we can see here is the probability that the regime used, so the state is model 2. So we can see that at the beginning, we have probability of anomaly or probability of regime 2, which is the accelerating regime, being close to 0. Then we have a large spike and going back to 0. And here we have, we are going to keep that in memory for later on. We have the autoregressive term. This green band is where we have missing data. So we see that whenever we have missing data, the models are going to automatically come in and fill the blank. So this is my residual term. I can close it for now. This is my period, the second component of my periodic term. I can close it. This represents the amplitude of my seasonal effects. This represents here my local acceleration, so the acceleration of my baseline. So representing the response of a system without the reversible effect, what you can see here, those that can be caused, for instance, by temperature or external action acting on the bridge. So I have here acceleration, I have here trend, which represents the speed. We can see a big drop in the speed here, and we can see the level. So we can see that this level here, and close this one, this level here, this drop in the responsive structure correspond with the case where I have an accelerating model. So we can see that we can go from a normal regime, we have a change in our normal regime, and we're going back to a normal situation. And that is well reflected in our raw time series, where we can see that here we have the missing data. Missing data didn't trigger any regime change. We have the data. It can realize that here I have a change in the regime. So I have that transition from one constant speed regime to an accelerating regime to going back to a constant speed regime. So this is what we have here. And what we can see, I'm going to quit here. What we can see if we zoom in is the red line are the observed data. The black line is the estimated response of the structure without the observation noise. And the green line is the confidence interval. Okay, so if we want to here export this data, we can go in OpenBDLM main, and we have the data optim number 5. We're going to export data, option 17, and we want to export the configuration file, option 1. Okay, it already exists. Do we want to overwrite? We're going to say no here because we already have it, but this would create that same configuration file that we have here. We choose quit, and this is what we have here, our same configuration, model 1, model 2, the constraint between our model, and we have all the parameters that were created with their optimized values. The estimated initial states and all the parameters for our analysis that is available for us to modify.